Hi, excuse me. Today we're going to talk about comparing proportional relationships. So comparing proportional graphs, tables, equations, or even word problems. So our first one, is this table proportional? So we just do y divided by x. So 9 divided by 3 equals 3. 12 divided by 4 equals 3. And if we just stop there, we're like, cool, looks great. We must be done. It's 3. No, never stop. We got to do y, which is 2, over 6, which is 1/3. And no, it's not the same, so no, this is not proportional. And because it's not proportional, I don't have to write the equation of the table. Our goal today, I can compare proportional relationships. So, some standing whiteboard practice. First, which of these is a proportional relationship? Straight line through 0, 0 for a graph, so B. And that's just looking at it, right? If this extended further, we could even find the constant of proportionality, which looks like it might be 1/5. So that's cool. Which table is proportional? Remember, it's y over x. 1/2 is 1/2. 3/6 is 1/2. 16/18, no, that should have been 9/18, so that's no good. Okay, 19/4, I can't do that in my head. I don't know what it is. 19/4 is 4.75. 54, that's not a 54. Okay. No undo. Okay, 54/11. 54/11 is not. It's 4.91. So this is also not proportional. Okay, 5/3. 5/3 is 1.67. Then 24/22 is just 1.01. Actually 1.1. So not proportional. So by default it must be D, but let's check just in case. 4/6 equals 0.6 repeating. 12/18 equals 0.6 repeating. 14/21 equals 0.6 repeating. And 18/27 equals 0.6 repeating. So this is proportional. The constant of proportionality is 0.6 repeating, which happens to be the fraction 2/3. Okay. A 7.5 inch candle burns down in 10 hours. If B represents how much of the candle in inches has burned away at any given time in hours T, write a proportional equation for B in terms of T that matches the context. Okay, that's like a lot of crazy vocabulary. All they really mean is, hey, write an equation so I can tell how far the candle might have burned. Okay? Well, if it takes a candle that's this tall, 17.5 inches, and it takes it 10 hours. So let's just split that whole candle up into chunks of 10, so we know how much every single hour is burning away. Then that 17.5 is same as 17.5. We can just move the decimal one space over, and we get 1.75. So B is equals, so the amount of candle burned is 1.75 per hour, or T is the amount of hours. So I guess we would write the answer down here. 1.75 T would be our answer. That's a challenge question. The proportional relationship between the number of sweaters a clothing store buys and sells, S, and the profit in dollars and cents that it makes off those sweaters can be represented by this equation. What is the constant of proportionality? 27. That's great. It's a whole word problem, but all they mean is here's the equation, what's the constant of proportionality? We know it's the number in the equation. Okay, here, again, there's a whole bunch of words. Here's a proportional relationship. Boom. What's the constant of proportionality? Boom. It's the number 1/9. Now that G looks like a 9. That's an unfortunate choice of theirs to use a G and a 9, but that's supposed to be a G, and that's supposed to be a 9, so it'd be 1/9 is our answer. All right, what is the rate of gas usage in miles per gallon? I love questions like this because it literally tells us, do the miles divided by the gallons. So we're just going to do the miles. 616 divided by the gallons. And it should be the same every single place we choose on the table. 22. There you go. So it was 22 miles per gallon. Not great, but not like the worst thing in the world. Okay, what's the constant of proportionality? We know that just means y over x. Excuse me, so we know it means dollars divided by time. 86.10 divided by 3 is $28.70 per hour. That's pretty great. Catherine buys 3 bottles of grapefruit juice at the corner store for a total cost of $2.31. If each bottle costs the same amount, how much is each bottle of juice? We're taking our money and splitting it up into 3 parts, right? So 2.31 divided by 3. That means each bottle was 77 cents. So our constant of proportionality is 0.77. Our unit rate is 0.77. Our unit price is 0.77. Whatever vocabulary we use for it, it means 1 bottle of grapefruit juice costs 0.77 or 77 cents. Okay, these next ones are going to be a little more difficult. That's why in class we do them in small groups. Oh, and longer, apparently. Jackson was comparing the price of steak at 2 stores. At Super Grocery A, 2 pounds of steak costs $13.72. The graph below, well, okay, the graph next to it, represents the total cost in dollars and cents. Why? That it costs for X pounds of steak at Super Grocery B. The question is, how much more expensive is it per pound to buy steak at grocery store B than at store A? So let's find the cost per pound. I love that, per pound. So it's money per pound. So I'm going to do this store A money, 13.72 divided by pounds. Okay, at this store, it's 6.86. Now at this store, we can use either this point or this point. It doesn't matter, except I just colored over that one, so I'm not going to use that one. I'm going to use this one. Money is 58.60, so $58.60 divided by 5 pounds of steak. This is $11.72, so much cheaper at grocery store A. Now, what's the quality? I don't know. That's not a thing they've talked about in this problem. But if we only care about price, grocery store A was cheaper. The question was, how much more expensive is it at store B? So that's just like saying, what's the difference? So I'm just going to subtract 11.72 minus 6.86. The difference is $4.86. That's a big difference. That's a big difference. But again, quality matters too. Okay, scientists are preparing 2 satellites to be launched. The equation y equals 400x represents the number of miles y that the satellite Space Explorer B, very creative, flies in x hours. The satellite Space Explorer A, again, great names, you guys, flies 36,400 miles in 13 hours. The question is, how many fewer miles does Space Explorer B travel in 1 hour than Space Explorer A? So we need miles per hour. So I'm just going to do the miles divided by the hours. Now we know Space Explorer B, they tell us it's 400. That's great. The other one we have to do some solving. 36,400 divided by 13. 36,400 divided by 13 equals what? That's a huge difference. Yeah, okay. 2,800. The question is, how many fewer miles? So really it's asking what's the difference. So we can just subtract 2,800 minus 400, which is 2,400. I would guess that these 2 satellites, or space explorers, the satellites, have 2 different purposes, because that's quite a difference in speed. So maybe their purposes are different, and that's why they have different speeds. I don't know. Or maybe one's a lot older than the other. Okay, Alonzo was comparing the price of pineapple juice at 2 stores. The equation y equals 1.76x represents what Alonzo would pay in dollars and cents y for x bottles of pineapple juice at store A. The table below, it's off to the side, represents what Alonzo would pay in dollars and cents y for x bottles of pineapple juice at store B. How much more is a bottle of pineapple juice at store A, is probably what that says, yep, than at store B? So again, like, what's the difference? Well, whenever we're dealing with money, we're going to do money divided by the number of bottles in this case. So I love these numbers. 13.13 divided by 13 is $1.01. And that should be the same for all of these. And it's asking what's the difference? Well, here is our number for the other one, $1.76. So we can just subtract $1.76 minus, oopsies, there we go, minus $1.01, and we get 75 cents difference, which I guess we could type in as the decimal, 0.75. And then some time for Alex homework. In our exit ticket, draw an example of a proportional graph, just a straight line through 0, 0. There you go. That was some proportional relationships in context. You got this.